So good morning. It's 11:45, so I figured we might as well get started. I was told that we were going to be starting 15 minutes later because the general session had went long. I've timed my presentation. It's about 40 minutes, so that should still leave you guys enough time, depending on the questions, to be able to get out at 12:30, 12:35 in time for lunch. So I'm a product evangelist here at MicroStrategy. My name is David Harsh, and I'm responsible for the big data validation engagements that we've been running with customers. So over the last few years, I've been traveling really all over the world to be able to promote some of the latest releases of our software, but then also to gain a greater understanding into what are some of the problems that some of our most strategic customers are trying to solve, especially with big data, right? And it's been really exciting because big data is rapidly evolving. And I think that MicroStrategy is also well positioned to integrate with this rapid development. Today what I'm going to talk to you all about is this new connector that we made generally available to each and every one of you guys with the release of 10.7 this last month. And that new connector is the Hadoop Gateway. So before I begin my presentation, I've been told that I need to mention this safe harbor notice. And so if at any point in this talk I am talking about the future vision of the product, neither I or MicroStrategy cannot commit to these development plans into the marketplace. However, so this statement just really covers me toward the end of the presentation if I were to talk about some of the future development plans, but I'm going to spend most of my presentation on what we've already released to the customers, what you all are able to get your hands on today, and that we've already been able to validate with customers. So why did we build the Hadoop Gateway? So in order to answer this question, I think that it's probably a good idea to take a step back and answer and really set the stage for big data, right? There is more data that is trying to be analyzed today than at any point in history, right? With big data technology, data can now be stored at a fraction of the cost, and there are plenty of new technologies that offer lightning fast performance improvements as we run queries, right? And this is why everybody's talking about big data, and to be honest, this is why you all are here. And if you talk to any BI company, they're going to say that the most frequently used connection to relational databases, and really big data technologies for that matter, is going to be an ODBC or JDBC driver, right? And so MicroStrategy offers these drivers as well. And with these drivers, you can use this semantic layer on top of a database. You could build a project schema. You could connect live. You could even apply a security filter. And this is something that a lot of customers are just getting used to using, right? But as you all know, that there are limitations with these ODBC drivers. And I think that these limitations are only exacerbated with big data technology, right? And so one of these limitations is what we call kind of an ODBC bottleneck. And so what do I mean by an ODBC bottleneck? It's when you're trying to take a large amount of data into MicroStrategy through a very thin ODBC driver thread, right? And so that's one limitation of some of these drivers. Another driver is that, or another limitation is that we require you all to load the data from your source files into Hive tables, right? And so that's kind of counterintuitive or counterproductive to a lot of big data technologies that are designed to bring data to the end user as quickly as possible, right? Why are you going to make them wait for that data to be then loaded into Hive tables? And so that's where the Hadoop Gateway comes in. The Hadoop Gateway is a new data processing engine deployed in HDFS that will process a user's request to publish files directly into memory. This empowers a business user to take advantage of raw files in ways that they've never been able to do before. And now the real performance value of this engine comes as data is transferred back to MicroStrategy in parallel without the need of an ODBC driver or JDBC driver. This leads to a great amount of performance improvement in the cube publication. This engine can currently be deployed for Cloudera and Hortonworks, and we do have plans to support MapR as well. And now, this gateway can help in the following scenarios. As I was talking about with this ODBC bottleneck, what the Hadoop gateway will help to do is greatly reduce the amount of data fetch and transfer time in cube publication. So as you all know, during cube publication, there's many different segments to cube publication, one of which is data transfer and fetch time. Now that segment itself can be greatly reduced with the Hadoop gateway. Now the big data cluster, let's say there's another scenario where the big data cluster admin is too busy, or which is probably very likely in your environments as big data is becoming bigger and bigger, they have 100 other tasks and they just don't have time to respond to your request right away. Okay? And so what the Hadoop gateway does is it empowers the business user to be able to directly connect to HDFS, to browse files, to preview those files, the data, and then ultimately publish those files into memory, into MicroStrategy. And so a lot of you guys are thinking, okay, great, I can publish a raw file into memory. Well, this is something else that's also what I really like about the Hadoop gateway, is we've actually streamlined the data wrangling process. So you can actually wrangle that file into a consumable format. And so what I also really like about the Hadoop gateway is I'm not just spinning stories and I'm not just talking in the theoretical right now. I'm going to be able to, toward the end of my presentation, talk very practically about what we've already been able to do on customer site, what we've already been able to validate on customer site. So I want to leave you all with a few kind of high-level speaking points and that we will then revisit toward the end of the presentation. But my goal is really to spark your interest, right? And so we're going to we went to the largest digital media company in the world, or one of them, and we were able to publish 500 million rows of data in less than an hour. And so this was more data that they were able to publish in a faster amount of time than they've ever been able to do before. We then went to one of the largest retailers in Europe, and we took raw transaction level data, we wrangled it, and published it in a consumable format, opening a new frontier of data possibilities for this customer. And then anybody that's interested in security would be interested in hearing about this, is that we went to one of the largest banks in the world and we were able to publish a cube against their environment that had been optimized for security and stability. They had enabled MIT Kerberos, and so that was something we were able to publish a cube against their Cloudera environment. So hopefully I've caught your attention. So now let me spend the next 30 minutes or so explaining the Hadoop gateway in a little bit deeper detail. What I'm going to do is spend about 3 minutes going over a product demo so that you can see the Hadoop gateway working in action, right? And then I'm going to explain the kind of a few architecture slides of the Hadoop gateway so you can conceptually begin to understand what's going on under the hood. That's very important, especially as we start talking about a lot of different moving pieces. And then I'm going to talk about how easy it is to install and configure. And finally, I'll finish my presentation highlighting a couple customer success stories. So for this first demo, what I want you all to do is put yourself in the shoes of a store manager. Actually, let me pause for a second. You guys, I see some of you all squinting. This is a presentation that my goal in the next couple of days is to publish on the MicroStrategy community. As I told you all, I'm a product evangelist. I want to turn each one of you guys into product evangelists when you go back to your different to your different companies. And so what I'm going to do is I'm going to put this on the community page. I'm going to have my slide deck and hopefully maybe even some more detailed instructions for anybody in your organization to be able to get their hands on the Hadoop gateway. So I don't want you to stress out if you can't see all the little things. This is by design. I want there to be as much detail in the video as possible, but that comes at the sacrifice of some people in the back. So for this demo, what we're going to do, put yourself in the shoes of a store manager that's analyzing profit for a bookstore in Florida. Okay, you've been told that summer's coming up and we should expect a summer bump in sales. Okay, and so you start to see that as well in what we have on the far right grid and visualization that's a report that's at the month level and at the profit level. Okay, so it's reporting the profit details. And you can see in the green, there's actually over a couple of the summer months, we are seeing a bump in profit, okay? And now if you're a good store manager, you know that there's a lot more to the number profit than just that number, right? You know that there could be an increase in revenue, there could be a decrease in cost, so you want to be able to drill down at that level. But you also want to be able to drill down a little bit further than month, right? You maybe at the week level, maybe at the day level, but you also know that maybe that's data that's pretty expensive to store in a database. And so what you know is that somebody down the hall is storing data, and he's begun to store day-level data with cost and revenue within HDFS. But then you remember, oh, shoot, John, your big data cluster admin, is on spring break with his kids, and he's unavailable to help you actually load this data into Hive, right? And that's when you remember, David at MicroStrategy World was telling me about this new Hadoop gateway that is going to allow us to publish a cube directly from files in HDFS, okay? So this is from the perspective of an end user. You're going to think, how did we get to some of these different workflows? And I'm going to backtrack in maybe 10 or 15 minutes where you're going to start to see how we actually install, how we actually configure. But this is from an end user's perspective once it's already set up. So let me kind of begin here. So you're in here, you click on Florida, you see that Florida also experiences this summer bump in sales. So what you want to do is from your data import interface, add external data, you navigate over to Hadoop. And let's assume that the gateway has already been configured and you can actually browse this HDFS file system. And a few things that I want to highlight about the file system is that we support multiple files to be published now. We support Avro, Org, Parquet, JSON files, CSV files, text files that you can publish. Also, security is maintained in this file browsing. If you're hovering over a specific folder and you do not have access, you'll only be able to click on it. You won't be able to actually drill in and see what's underneath that folder. The final thing that's probably pretty exciting is that when the folder is saved with the file extension, it can be dragged over to the data import interface. And in this case, the daily transaction folder is the parent of all the transaction level data. And this is the cool part. As long as all of the underlying files have the same file structure, the cube will be published. At cube publication, the partitions will be unioned together into one table. So we get into the file and we see it's not exactly in the right format, but we don't have to reach out to the big data cluster admin. We can navigate to the data wrangling interface so that we can wrangle this data on the fly. And in this interface, we can add columns, we can manipulate columns, we can even add a preloaded script that we can apply to this Parquet file. And so now we can go back to the data set and ensure that the different columns will be imported properly. Here we can change the data type and convert attributes to metrics. And now we're going to start the cube publication process. So I'll save the details of kind of what's going on under the hood for right now, but you can navigate over to Ambari, or if any Cloudera users are in the room, you could go to Cloudera Manager, and you can see that the application is running. You can go in and you can actually view that the jobs have been kicked off and that the cube publication process is underway. And so once the cube is actually published, we're in business. We can link the month to the top data set, and now we have the top data set acting as a filter for the daily transaction data that we have just loaded into HDFS. Let's see. So the following is a high-level architecture overview of what the Hadoop gateway looks like. And as I just showed you in the demo, jobs are submitted from the intelligence server to the Hadoop gateway. The Hadoop gateway will then take these requests and submit these requests to a Spark master or a Yarn service. This resource negotiator will then handle the jobs that are submitted to Spark. So these requests will then be processed in parallel and sent back to the intelligence server in parallel. And so this is where the connector is going to realize that performance improvement. If a user were to publish a cube with a ODBC driver, the jobs might be kicked off in parallel, but as soon as the data is being brought back into memory, it's going to be constrained by that ODBC connection. So the Hadoop gateway supports 3 different connection modes: Yarn, standalone, and local. Yarn is the most frequently used connection mode that most customers are interested in. This mode even supports shared Kerberos. So the Yarn mode requires that the Yarn service is enabled on your Hadoop cluster. And so what will happen is the driver runs in the client process, and the application master is only used for requesting resources from Yarn. And now, if Yarn is not enabled, you can use your standalone connection to directly connect to your Spark master service. And in this mode, the Hadoop gateway uses the Spark master to coordinate the data processing. So finally, in your local mode, there's no application that's deployed against your Spark nodes. All the data processing is executed in the Hadoop gateway host. This mode is intended for testing and troubleshooting different connection issues, right? So what we're going to do now is talk through 3 different stages of the Hadoop gateway. So the first stage is going to be your file browsing and previewing the data. Then the second stage that I'm going to discuss is deploying the gateway, configuring the gateway, showing how easy it is to install the gateway. And then the third stage that I'll talk about is cube publication. So for the first stage, MicroStrategy is going to connect directly to the name node of the Hadoop cluster in order to browse the HDFS file system and then ultimately preview the data. When configuring the connection to Hadoop, a user will establish the HDFS and web HDFS ports that the cluster uses. This will then allow a user to be able to preview the first 1,000 rows of data. Now, in some instances, the Hadoop gateway will be invoked in order to kick off certain jobs to the worker nodes in order to retrieve the first 1,000 rows of specific file formats. But for all intents and purposes, this is a very simple kind of architecture drawing of what's going on as you're especially browsing the file system. So the next process that I'm going to talk about is deploying the gateway. And this section is going to be particularly exciting for all of you guys that are familiar with the big data engine, or what we had developed a couple years ago. And for all of you guys that have been really trying to use that, we acknowledge that it's clunky to install, it's hard to configure, especially with a rapidly evolving Cloudera or Hortonworks distribution, right? And so now this deployment only entails installing the gateway on one node, typically the edge node of your cluster, and then starting the application. So MicroStrategy provides 2 different ways to do this. One way is automatically through MicroStrategy Web, and the second way is through manual deployment. So I'm going to show you just 2-minute demos of the Hadoop gateway working and being deployed. So this is from MicroStrategy Web. What we're going to see is we're going to navigate to the data import interface, and we navigate to click Hadoop. And now from this portal, you can navigate to the Gateway Manager. And this is where you're going to add all your cluster configuration. So for this, you'll need your machine name or IP address for your name node, and then also where you want to install the Hadoop gateway. So as I mentioned, probably your edge node. And you'll also want to define a few ports, like the HDFS port, your web HDFS port, and then the Hadoop gateway port. And this is going to be defined. Typically, your big data cluster admin can provide this information for you. And then next, you're going to select the connection mode. And depending on the connection mode that a customer selects, they'll have to slightly modify the configuration parameters. But they are fairly straightforward and can get this information from the cluster admin. So for Yarn, you'll need the HDFS jar path for your Spark assembly.jar file. For your standalone, you're going to need the Spark service address. And then finally, for local mode, you'll just define the amount of threads you want to simulate. So finally, you'll have the option to select a few advanced parameters and settings that we can use to optimize or constrain performance, however you see fit. So once we do this, we can deploy the gateway, and we're going through the process of actually starting the gateway now. And once it's started, what we can do is we can go back and verify that the file browsing interface is set up for all of our end users. And this is just going to ensure that the web HDFS and your HDFS ports are defined properly. And then we can navigate to the Yarn application and ensure that the application is properly started. And so even what we found when I went on customer site is, even though you might not be a big data cluster admin, typically this URL and this address is open to anybody that's in the network to at least be able to monitor the Yarn applications that are running, and then so you can see what's going on in the jobs. So that's just something for you to be aware of as you're getting this gateway set up, for you to be able to, hey, big data cluster admin, can I get access to this URL to be able to monitor the Yarn application? And so now next, I'm going to talk about the manual deployment of the Hadoop gateway. And so for many of you all, you're probably thinking that's a pretty intimidating phrase, manual deployment, right? And so, but that's why I think that it's worthwhile to highlight how easy it is to set up. At a high level, all you have to do is download a tar package onto your edge node, untar this package, update one Spark properties file, and then start the application, right? So I'm going to show you this short 2-minute video, and I see a lot of cameras kind of being brought out, and that's totally okay. I recognize that it is low resolution. I'm going to do my best job to narrate what's going on, but also know that when I post this on the community, you'll be able to see exactly what's going on. So what we did is we download the Hadoop gateway from the download site, and we unzip that file on our local machine. Okay? Once we unzip that file, we can then transfer that file over to the edge node through an SCP command. I'm only going into the details of this process because it really is so easy. And so once we've transferred that file over to the edge node, all we have to do is SSH into the edge node, so navigate over to the edge node, and we're going to make a couple copies of 2 template files that we deploy, that we send out with the Hadoop gateway. These files are the Spark properties file, and that's where you're going to add all the configuration. And then also the log4j properties file. And that's a file that's just going to establish what are the types of logs that are going to be logged when we start up this application on the edge node. And so we see that we've made the copy of those 2 template files, and we navigate over to the Spark properties file. And all of these parameters is exactly what you just saw us update in MicroStrategy Web. And so I won't go into all the details of what we are updating, but what I'm going to add is the jar path because we've set up a connection to the Yarn client. And so once we've defined the jar path of your Spark assembly file, we can go ahead and start the gateway. Once we start the gateway, we can verify that it's up and running by going back to Yarn and seeing that it's already there, already running. So very straightforward, very easy, and I hope that that video is going to be helpful for anybody that's going to get their hands dirty with the Hadoop Gateway manual install. So let's revisit the kind of the 3 stages of the Hadoop Gateway. So we first talked about the preview of the data and the file browsing of the data, right? And that was, we talked about that. All you have to do is set up a connection to your HDFS and web HDFS ports on the name node. And then the second stage that we have talked about is deploying the gateway, right? And that's very simple, very straightforward. You take one tar file on the edge node, you copy a few files, and you start the application. And now this is where we get to the fun part. This is where we talk about the kube publication, right? And so the first thing that's going to happen during kube publication is that the web server is going to inform the intelligence server, hey, I want to publish a kube. And so they're going to send a request to the Hadoop gateway with the file path and schema info of the file to be published. Then the Hadoop gateway will create jobs to be submitted to Yarn. And these jobs in our code are called the BDE requests. And these will be submitted via an HDFS protocol. And then the Hadoop gateway server will inform each one of the Spark master nodes, or will inform the Spark master node, which will then inform all the different worker nodes to fetch the data and perform any data wrangling that it needs to happen. And so you can go to the Yarn service and see that the job's been kicked off and that the jobs are in an active stage executing in parallel. And so a single request might have multiple jobs, and those multiple jobs might have multiple stages, and those stages might have multiple tasks. Your big data cluster admin is going to be more familiar, especially with that, than maybe some of you all in the room that are not as familiar with Yarn. But that's just a helpful resource to reach out to if you're not sure what's going on at that point during the process. And then at this point is when the Spark worker nodes are going to process the request and send the data back to the intelligence server. So TCP is being used to send data back from the worker nodes to the intelligence server. TCP is a transmission control protocol, and so this is going to guarantee the delivery of the data and also guarantees that the packets will be delivered in the same order in which they were sent. So once the data is brought back to MicroStrategy, MicroStrategy will merge the data from these pieces to publish the cube. So I've said this multiple times today, but the real performance gain of the Hadoop gateway is in the parallel data transfer directly from Hadoop over to the intelligence server. So if you look at the top table, you're going to see that the transfer times of some of our testing in the last couple of months. So even in optimal network conditions, the best data transfer time that I've seen from a database into an intelligence server is about 20 megabytes per second. And now, if we analyze these same numbers for the Hadoop gateway, we see an exponentially better data transfer speed as the size of the cube grows. So practically, what do I mean by data transfer speed? I kind of alluded to that earlier on in my presentation, but what I want you to do is look at the bottom right of this slide, and this is a sample output of cube details. And so when you're publishing a cube, as I mentioned, there are multiple segments, right? And so this cube details section talks about the query engine execution start time, the execution finish time, how long the query execution time took, and then so what I highlighted is the sum of data fetching and processing time. And then also the transfer time as well, which is the same number. And those two rows are going to be the number that can be reduced with the Hadoop gateway. And so what you'll see, what does this mean, right? So when we are transferring data and we're publishing a cube that's 1 gigabytes, with the Hadoop gateway, from what we've seen in-house, it would only take 20 seconds to transfer that data into MicroStrategy. With an ODBC driver, it would take 50 seconds. You fast forward up to a 100 gigabyte cube, and we see that that data transfer time can be just a little under, let's see, 136 seconds, a little over 2 minutes with the Hadoop gateway, and about 85 minutes with the ODBC driver. So this is where you're going to really see that performance gain. So as promised, the rest of the presentation that I'm going to spend, I'm going to spend talking about the customers that we've been able to go and actually validate this Hadoop gateway with. And so we've seen a wide variety of use cases achieved. And now let me take you down through one customer at a time. So the first customer that I'll highlight is one of the largest digital media companies in the world. So this company was looking to publish a rapidly growing set of viewership data into memory from all their digital media platforms, right? And it was taking hours to publish from Hive via a thin ODBC pipe, okay? And so before our team came on site, the business intelligence team at this customer saw that 150 million rows of data was taking nearly 6 hours to publish in Hive and only about 30 minutes with Teradata. That being said, Teradata did require about 30 minutes of additional time to normalize this data into a way that, well, it would just optimize the performance. So our requirements for success with this customer was, hey, could we showcase the Hadoop gateway's ability to publish cubes directly against HDFS without having to create Hive tables, normalize tables in Teradata, and in less time than Teradata? And MicroStrategy did just that. We published a 150 million row cube in about 24 minutes, and by the end of the engagement with this customer, we were able to publish 500 million rows of data in less than an hour with the Hadoop gateway. And so this was more data in a faster amount of time than they've ever been able to publish. A couple notes about this customer is that the customer was using one of their development clusters with Hortonworks 242. And so this development cluster only had 2 worker nodes. And so each worker node did have 380 gigabytes of RAM and 40 virtual cores, but they only had 2 worker nodes. And if you compare that to their production, they had about 51 worker nodes. So they were really excited to see that we were getting that type of performance against their dev cluster. And they were really excited to be able to get their hands on a production use case as well. So another thing that we observed while on site was that the Parquet files that we were publishing were processing faster than ORC files. So you all know that Parquet files, ORC files have kind of different compression ratios, and so by that logic, you can also know that those files are going to be stored with different sizes on HDFS. But those files might take a different amount of time to actually publish with the Hadoop gateway, but not necessarily because of the Hadoop gateway, but just as Hadoop is running through that process. What we've seen is once you get the data in-house between Hive on Spark, between Teradata, between the Hadoop gateway, once the data is in-house and it's actually publishing, it's going to take about the same amount of time. And so that's why we're trying to optimize that data transfer time. And so I just figured that would be strong insight as you're beginning to navigate and investigate this new Hadoop gateway. So another company I went to about a month ago was one of the largest retailers in Europe. So last year, executives at this company had begun heavily investing in big data initiatives that would allow this customer to be more proactive in responding to market trends and sales anomalies. They began loading daily transaction data, which amounted to about 12 million rows of data per day, into Parquet and Avro files. However, they wouldn't be able to report on this data until that data had been loaded into Hive. So they were excited to hear about the Hadoop gateway's ability to give their end users direct access into HDFS to publish those files. So our requirements for this visit were kind of twofold. One, could the Hadoop gateway perform, but also could it publish files in a way that would be consumable, right? And so on both fronts, we were successful in doing that as well. So we took the raw daily transaction files and loaded this data into Hive. And so what we did is we kind of ran 2 different comparison tests. We were comparing the Hadoop gateway on the left to the Hive on Spark data on the right. And so in the top 2 bars, what you'll see is the transaction cube. That's at the raw data level, right? And then the bottom 2 rows are where you see the transaction cube with data wrangling, okay? And so what was interesting is, so the Hadoop gateway was able to outperform Hive on Spark. The 2 bars up at the top row, you'll see that the Hadoop gateway was able to perform faster than Hive on Spark. But this is what's interesting. If you look at the bottom row on the Hadoop gateway side, the bottom left bar, that bar is still faster than Hive on Spark's raw data. And so this was really exciting for the customer. And let's say that we then compare directly Hive on Spark with the Hadoop gateway with data wrangling. The comparison just becomes unfair. You see that there's a lot more other processing time. You see an orange bar at the bottom right at the top of the Q publication for Hive on Spark. And so why is that? The reason why we have that orange bar is that the Hadoop gateway, as I mentioned, pushes down data wrangling functionality to Hadoop. And so the data is actually being brought back in a cleansed format already. So we're able to leverage the Hadoop for the data cleansing process. And so it's brought back, and then we don't have much cleaning going on, which we had to do when we brought back the data with Hive on Spark. So that was something that was a pretty cool insight that we learned from this customer. So the last customer that I'll talk about is one of the largest banks in the world that we went to. The team that I worked most closely with was responsible for the MicroStrategy certification. So if any feature was going to kind of be used at this customer, it had to go through this team first before being disseminated to the different application teams. So the number one concern that this bank had was if our new feature could handle the configuration of their Hadoop cluster that had been optimized for security and stability. And so we were able to do that. I mean, the success criteria was fairly straightforward. Hey, go against the Hadoop cluster that we have set up and publish a cube, right? But this is what was interesting, is that they had enabled MIT Kerberos for the data access and authentication. So with MIT Kerberos, the Hadoop gateway can identify itself as a Kerberos principal and have access to the required services within HDFS or your Spark manager. And then they also enabled SSL, or what you may be familiar with, like HTTPS, right? So just for some more context, the Hadoop clusters exchange data internally via HTTP, right? And so since these HTTP transfers the data in clear text, and an attacker might be able to go in and get access into some of your valuable data. And this would be put your data at risk. And so to protect their data, they had enabled SSL, they had set up HTTPS. We were able to kind of work through that as well. And then finally, they had enabled high availability on Cloudera Manager. And this is something that you can set at your HDFS or at Yarn service level, and where a server node can be set as active. And then you also define a couple additional nodes as your standby nodes in case something were to happen to your active node. And so they had done all of these different things, and we were able to publish a cube. And so on all fronts, you can see that we were able to validate the Hadoop gateway with various different use cases, and see that it could add value in a lot of different kind of industries as well. So the last thing that I'll say in this presentation is that where there's an open mind, there will always be a new frontier. Charles Kettering said that. He was the head of research for GM for 20 plus years. And so we're connecting to that new frontier. And with this new gateway, we're going to empower business users to be able to get their hands further upstream into data that they had never been able to access before, and in a faster amount of time than they've ever been able to do before. And now this narrative is something that we're only going to be able to continue to build on in the future. You can kind of see how we've laid the groundwork with the Hadoop gateway. And so with the Hadoop gateway, we've empowered users to get their hands on raw HDFS files today and wrangle that data. But there have been a lot of customer requests, and we know that this is the next logical thing in the process of the Hadoop gateway, is to be able to take these files and aggregate those files, or take those raw files in HDFS and be able to filter those files. And so we acknowledge that that's the next step in our roadmap, and we're going to be working toward that as well. And for a large part, this is going to probably eliminate a lot of the need to run a lot of ETL jobs against Hive that companies are already doing, if you can take these raw files and already aggregate those raw files into aggregation tables. So MicroStrategy is also investing in our ability to be able to connect directly to Spark's memory layer. Now, so in essence, we would have 3 different tiers of data. We would be able to connect to Hadoop, and then Spark memory, and then finally, we'd be able to connect to the MicroStrategy memory. And so I don't want to spend too much time talking about that, because we're going to talk about that at MicroStrategy Futures tomorrow, and I don't want to steal their thunder. But I think that it's a good reminder for you all to see that this gateway is kind of the first of that step in that direction, right? So anyway, with that said, does anybody have questions? We're wrapping up. It's about 12:24. I would love to answer some questions.
When you refer to
Sure.
When you refer to the Spark, you're talking about Apache Spark.
Sure. Yes. So it would be the Spark that can be run on Cloudera or Hortonworks, and yeah, Apache Spark would be something that I'm talking about. Yes, sir.
By the way, now the fact that we have this coming in, it's going to be a really awesome product. I have a couple of questions. The first one is with respect to performance. As you mentioned, obviously performance is going to be based on the size of the Hadoop cluster. However, is there an upper limit? Since you are using TCP, I mean, is there an upper limit to how much gains you can make?